Why did the scientist drop his wristwatch in a flask?
I'm not sure. Why?
He was looking for a timely solution.
Oh man, I slapped my knee on that one.
All periodic punning aside, today we're going to teach you how to perform the iodine clock reaction.
The iodine clock is classified as a chemical clock reaction, which combines three redox reactions. Reactions such as these occur when the concentration of one chemical abruptly changes. This leads to a sudden change in color.
This reaction was first discovered by Hans Heinrich Landolt in 1886. The reaction occurs when a solution of potassium iodate is combined with a solution of sodium metabisulfite, starch, and sulfuric acid. These two colorless solutions combine, and after a duration of time, they change to become dark blue in color.
To begin, take safety precaution. Wear safety goggles at all times, as all of these chemicals irritate the eyes upon contact. Take special precaution with the sulfuric acid. This chemical is corrosive to the eyes and skin, and inhalation causes respiratory irritation.
Now that we're all safe, we can begin. Add 2.58 grams of potassium iodate to 600 milliliters of distilled water. Label this solution A.
Next, add 4 grams of soluble starch into 100 milliliters of distilled water. Slowly add this to 900 milliliters of boiling water. Boil for a few more minutes before adding 0.2 grams of sodium metabisulfate and 5 milliliters of sulfuric acid. Stir until dissolved. Then let cool. Label this solution B.
Now the iodine clock received its namesake since different dilutions of solution A could accurately change the speed of the reaction. To demonstrate this property, we will model the reaction with 3 different dilutions of solution A.
Set out 3 50 milliliter beakers. Pour 20 milliliters of solution A into the first beaker, 25 milliliters into the second, and 30 milliliters into the third. Dilute each to 30 milliliters. Next, add 30 milliliters of solution B to each beaker. Step back and wait for the color change. So you may be wondering, what's happening with the reaction? In solution B, the sodium metabisulfite forms sodium bisulfite. This sodium bisulfite then ionizes to form a spectator sodium ion and bisulfite ion. Similarly, potassium iodate ionizes to form a spectator potassium ion and iodate ion. Sulfuric acid also ionizes to a hydrogen and sulfite ion.
The actual iodine clock is composed of 3 competing reactions. In the first reaction, which can be thought of as a decomposition reaction, the iodate ion reacts with the bisulfate ion to produce iodide ions, sulfate ions, and hydrogen ions.
In the second reaction, which can be thought of as a synthesis reaction, the iodide and hydrogen ion react with the excess iodate ions to produce molecular iodine and water.
Before the iodine can react with the starch to produce a dark blue color, it immediately reacts with the bisulfite ions to form iodide ions. Thus, the third reaction, which can be thought of as single displacement, depicts the bisulfite, iodine, and water reacting to convert the iodine back to iodide ions.
However, once all the bisulfite ions have reacted, the iodine is free to react with the starch to form that familiar dark blue color.
And that, everyone, is how to perform the infamous iodine clock reaction. Thanks for listening.